And Jay shared a comment that I thought was really interesting as we kind of look back at over time. He said, IoT applications are like a 40-layer cake, an intricate stack of technologies, vendors and disciplines working in sync. And today we're going to be looking at kind of peeling that back a little bit. Often we think about IoT as just a device, but there is a lot of people involved, from vendors to technologies to many other things. And so I'm real excited today to be able to have the panel here with me. Why don't we go around and kind of give our name, company title, and what excites you about IoT. Richard, why don't you start us off?
Hey everyone. Check one. There we go. Hi everyone. Thank you for the time today. So Richard Z. I run our channel program at Freshworks. Freshworks is a information technology system, really ticketing. So we deliver solutions for IT, facilities, site supervisors to bring data into so they can do their job well. Really what excites me is manufacturing. Everybody's starting to collect data. They don't know what to do with that data. And we think we have a unique way to surface that to leaders to be predictive, to increase productivity. And so that's what we're here to talk about today.
Thanks, Rich. Pat, you want to give us?
Yeah, good morning. My name is Pat O'Donnell. I'm the CEO of Shelfmark. We're a Pittsburgh-based AI visual inspection automation platform for manufacturers. We started Shelfmark entirely following the needs of our customers, and our customers have three things in common. One, American manufacturers struggle to find labor. Two, 90% of them manually inspect the products that they produce. And three, because of those two things, every manufacturer wants to automate with AI, but tools in the market aren't necessarily built for the mid-market, built for manufacturers in cities like Cleveland or Pittsburgh. And so our Shelfmark platform is an all-inclusive hardware, software, machine learning, and data platform that automates visual inspection from zero to full automation. I'm excited about IoT because of what it enables in use cases like ours. Right? IoT is the highway on which we get to build all these awesome super race cars, AI platforms that wouldn't be possible without the data that IoT unlocks. And so very excited to dig into that a bit today.
Thanks, Pat. Evan?
My name is Evan Karnapakis. I'm an at-large director and board member of the IoT Sandbox. And what excites me about IoT is that blockchain, which has often been called a solution in search of a problem, is in fact a solution to many of the most prominent challenges that IoT faces.
Awesome, thanks, Evan. I'd like to transition and start to talk about some of the application areas that each of you are, I'm going to say, working with today. So Evan, why don't we kind of start out with you and start to talk about where you're working in IoT and some of the application areas that you're seeing.
So IoT devices generate a profusion of what we call microservice transactions. Now, blockchain, specifically the smart contracts within a blockchain, automate routine transactions and deliver on compliant transactions in a trusted and transparent manner without the need for traditional third-party authenticators and validators whose processing fees often make these transactions cost prohibitive. Now, where I think there's an excellent application for this combination of blockchain and IoT is with ensuring temperature integrity for medications within a supply chain. So how does this work? Well, you can use the IoT devices to track the temperature data and then store it on a blockchain as a way to guarantee that those regulatory requirements are maintained. Now, before you have the intersection of these two technologies, the only way to really ensure that regulatory temperature compliance was with refrigerated transportation. However, this would often drive up the cost sometimes by a factor of 4 to even 8 times the expense. With these IoT sensors, this is often unnecessary because in many instances the temperature can go as high as a maximum allowable 86 degrees. So as a result, this can save billions of dollars. So at the end of this supply chain, you can transfer the rest of the remaining data securely onto a blockchain, and then a smart contract can compare that immutable audit trail of temperature data against whatever the regulatory requirements are. This streamlines your compliant process and reduces your expenses.
Awesome, thanks Evan. That story kind of reminds me of when I was back and I was a kid unloading semi-trucks at Super Kmart, for those of you that remember, and the watermelons were actually exploding because they were so hot. So we needed IoT and blockchain on that truck. Pat, talk to us about what you're doing in the IoT area.
Yeah, of course. So I'm going to get as tangible as possible, because I think we hear AI, we hear IoT, they can sound very buzzwordy, but these solutions are deployed today, making real impact in real businesses in communities like Northeast Ohio and Western Pennsylvania. And so the example I'm going to cite is in the decorated apparel industry. So think custom t-shirts, hats, jerseys, etc. These products are made on, think industrial grade printers, right? Printing out logos that go onto a t-shirt, get heat pressed onto a shirt and onto the customer. In this industry, there's a struggle with a high defect rate, around 10% in that industrial printing process. And so many of these manufacturers, these printers, have staff, have labor that are sitting there monitoring these printers, watching, babysitting these printers every second of every day. Well, we did an implementation for a player in this space, installed cameras directly onto the print head of these printers to monitor for defects and automate that defect detection. And so, in doing that, we showed tremendous results just purely from an operational perspective, right? 90% reduction in waste, cut labor costs in half, created a 7x ROI on the investment that manufacturer made in automation. But where this really gets interesting and where it ties into IoT is the data that's being produced through this automation. So not only do we have cameras with AI that are automatically monitoring defects and creating defects data, we also, embedded in our cameras, have temperature and humidity sensors, which for those that know IoT and know these sensors, they're $1, $2, $3 sensors. This is not an expensive addition. But what this unlocks for our customers is that we've created, to our knowledge, the largest data set in the world that reliably correlates or relates temperature, humidity, and defect rate. And so by correlating those things and using those IoT devices to capture that data, we've been able to create this massive data set that then informs executive decision making, informs capital decisions for this customer. They anecdotally knew that temperature and humidity contributed to defects. We were now able to show that to them in hard data. They used that data to then make a capital decision to invest in humidity controls for their manufacturing facility and reduce their net defect rate. So, I share that example because I think that it explains and shows how IoT, AI come together on a manufacturing floor here in the region, right, making a real impact for manufacturers.
Thank you, Pat. And I just think back, your whole story reminds me of the invention of air conditioning, right? The printing press was struggling with humidity issues and designed the air conditioner by accident, right? And it's really amazing, right, as we look at production lines today and say, what is it that's driving the defect rate, and being able to prove that out. Rich, how about you? What are you working on in IoT?
Yeah, so we really focus specifically in manufacturing around the application layer and creating relationships. So if you think about a production line, there's a lot of different pieces of IT that are touching that line, and what goes down is very important. So what we do with our configuration management tool is we go and collect all the relationships that are out there. So now IT, engineering, if a major incident happens, they have all the information that they need to go remediate that incident. We work with a very large car manufacturer. They were actually having 2 major incidents a month, which was costing them $500 a minute once that site went down. We were able to reduce that time to remediation by 30% because now when that alert comes in, they know every piece of technology that is touching where that issue is happening. And so not only does it help with their response times, it also helps with their change management. So you think about patching and all that stuff that goes into the application, now they know everybody that's affected by that. So really, we focus around the data collection to help teams be smarter and more reactive when things do happen.
Oh, perfect. And some, sorry, got out of sequence, guys, here.
So Tim, what applications for IoT do you see?
Yeah, excellent. Yeah, some of the areas that we're working in is in the steel processing industry. So we have a lot of folks out here that are working with uncoiling and coiling steel. And so we've embedded IoT sensors inside of those lines, and we're able to reduce the MTBF on that equipment from 6 months to about 2 years by building a digital twin and being able to build a processing engine around that to be able to predict wear inside the machines. Some of the other things that we're working on is in the healthcare space. I know Locator X was talking about tracking high-value equipment, and we are working with the ventilators and BiPAP machines and actually integrating that back into the electronic health records to show them, hey, where is your equipment at? Someone passed away, is it in grandma's basement, or is it in the backyard of someone else's machine? So let's transition here. One of the areas that I think about when we're talking about IoT data is there's 3 general phases of dealing with the IoT data. It's that generating or the processing of that data, there's securing it, and then my favorite layer is exposing it. So as we kind of think through those 3 areas, a lot of times we forget that Evan here on the panel has a lot of experience in the blockchain side of securing it. And then Richard here has a lot of experience with the exposing side. Why don't we kind of step through each of you here and start to talk about, let's start with capturing the data. Pat, why don't you talk about capturing the data, kind of sensor data and the like?
Yeah, absolutely. So, couple of thoughts on capturing the data, right? When you look at capturing IoT data, the best way to think about it, I think we heard this on the previous panel, is what is the simplest, most cost-effective way to get the data that you need to drive decision-making, right? So, when you think about our product, right, you think about visual inspection automation, the AI technology, the deep learning computer vision that is able to perform this analysis and identify defects in products is really, really complex. But the output of that analysis is really, really simple, right? It's a good, not good. It's a very simple, is there a defect, is there not a defect, right? And so for us, in the way we think about capturing data, it's what's the simplest possible way to get that data in a consumable format, right? For us, that means we create an independent platform that has that defect data, has temperature, has humidity data, in order to essentially answer the questions that our customers need. So, when we think about capturing, think simple, think affordable, and think about your customers or your needs. What do you need to answer the questions that you want to answer? It might be temperature, it might be humidity, it might be pressure, whatever it is. Make it as simple as possible, because the rest of this, I think, as we've established, is hard enough. Keep it simple.
Thank you, Pat. And I think we've heard that this morning, right? In that iteration of the Industrial 4.0 is start small, right? Start to build off that. I know Richard and I were on a call recently. Richard, why don't you talk a little bit about that specific manufacturer and how they're working through that process?
Yeah, absolutely. So this manufacturer, they make barcodes for medical devices, syringes, things like that. And so they've been collecting data actually since 2013. And their biggest challenge is they have the data, but they have no way to surface it to the actual influencers that can stop a job if humidity is, increasing or the temperature is increasing, defects are rising. So what we're doing is we're actually building a standard operating procedure around these different leading indicators on when defects are going to increase and getting that to the third shift supervisor or the operator. And now there's a level of accountability because a lot of times a controller, they hear the defects going and they just let it go and let the roll go and then try to figure it out later. Now you can actually create a ticket and stop them in their tracks and say, hey, here's your operating procedure on what you need to do based on the data that we have. And then leveraging our Gen AI, as all this data is coming in, now you can surface kind of best practices around, what those operating procedures should be. So, and this can be really across industry because, creating efficiencies and increasing productivity is important. They already have the data, now it's just surfacing it.
Yeah, thanks, Richard. And I know one of the things that was interesting to me as we're talking through the production line managers is it's not always something that we think about is how do you raise that to the machine operator? They may not have an HMI. How do you bring that to their attention and give them the next step to take? So as production line managers, often they have to think through, what do I do with this data? How do I expose it? How do I tell the operator what to do next? Let's shift to securing the data. Evan, how do you secure IoT data to ensure that it's trustworthy and scalable?
Well, IoT devices with their rudimentary operating systems have limited capabilities in terms of transmission, processing, storage, and security of data. But blockchain can help with this. Now, as an example, there's a company called Helium that created a wireless mesh network for IoT devices to transmit data. And they did this in a rather ingenious way. Instead of raising the capital for a traditional, very expensive cellular infrastructure, what they did is they sold individuals these nodes for the network called hotspots. Now, the way this worked is as those hotspots were turned on and connected to each other, they received tokens for validating other hotspots as they built out the network. And this was a rather ingenious way to deal with the typical chicken or egg dilemma of a two-sided marketplace. This enabled them to effectively scale the supply side by creating this availability of capacity for transmitting data before that supply actually existed. Now, some other things that blockchain did here was there's often a problem with IoT devices in terms of counterfeiting. Well, with this network, once an IoT device is authenticated, it can roam through the network from node to node without needing to re-authenticate. Again, disintermediating those third parties there. Also, the IoT device can kick off a transaction that will pay the node operators, again, without the need, again, executed by smart contracts, without the need for third-party validators driving up expenses. Now, in terms of securing the data, blockchain uses what are called consensus algorithms, and once these nodes agree and validate the data, it's written to the blockchain in a sequential time-step manner. Now, this data is going to be secured for two reasons. The first is that it's immutable, you can't change it. Now, if there's an incorrect transaction, you can reverse it, but it requires the approval of 51% of the nodes that are operating. Therefore, a malicious actor, instead of just having one centralized database hack, would need to hack more than half of the nodes on the system. The other issue is that these node operators are incentivized by the tokens they receive to maintain the integrity of the network. If that was somehow compromised, then those network tokens would lose their value.
Excellent. So how would we, talking to the SMB market, right, maybe mid-level enterprise, how might that be able to adopt blockchain, I'm going to say in the beginner steps?
So referring to then moving on to the fact that if you don't have a traditional centralized database.
Yeah, if they're not using Helium per se, how might an SMB or mid-level enterprise be able to, say, adopt blockchain?
Could you be more specific in terms of, like, trying to figure out what type of example that you're looking for?
Yeah, I'm just trying to, as we're I'm thinking through the audience perspectives, right? Blockchain sounds like something that's big, it's scary, it's hard to know. What might be the first step for an SMB or mid-level enterprise be to maybe take a step towards looking at blockchain or adopting blockchain?
Okay. What I would say is, again, I mentioned at the very beginning, the blockchain is often, has been called a solution in search of a problem. And there was this hype cycle years ago where everyone was saying we're going to do blockchain, we're going to mine, and then as a result, much like the internet, if you remember from 25 years ago, everything was going to be on the internet, all these .coms were created. We saw the same thing happen with blockchain several years ago. But I wrote an article about 6 years ago, and what I did is I identified 5 criteria that you can use for determining whether or not blockchain makes sense in your business. And these actually overlap very well with IoT. The first is simplification through automating routine transactions. Do you have that opportunity there? And then delivering on those compliant transactions without third-party intermediaries. Second, what we call trustless trust. Do you have this need for transparency and trust between parties who don't necessarily have contact with each other, such as throughout the various steps of a blockchain? Third, you have a need for provenance, meaning understanding the complete origin and history of a product. Then there is what we call balancing data security with data sovereignty, having ownership of that data yourself instead of it being siloed in a centralized database. And the last one, which is probably the most important, is it attainable? You need to know, do you have the physical infrastructure in place? Do you have the financial capital? And then is there the human capital? And this is a situation where all of these have been improving over the last 5-6 years. We're seeing more favorable regulatory requirements. More people are learning the software skills necessary to build blockchains, and there's an increased confidence as we're seeing these projects move beyond the white paper to the product concept, to the minimum viable product phase, and now we're seeing full-blown implementations that are adding value here, combining blockchain with IoT.
Thanks, Evan. I really appreciate that.
Yeah, and if I could just briefly build on that, I think on the attainability piece, an important point I heard Richard touch on this earlier with is user adoption. And all of this incredible technology that is out there is fabulous in theory, but it's worthless unless you can get your employees, your workers to adopt it and benefit from it, right? So Richard was talking about the defect alarm that's going off, but no one really cares because they got a lot of stuff going on, right? So you invest in all this awesome technology, you don't get the results from it because that machine-human interface, right, isn't established in a way that makes it valuable, right? So that's something that we talk about with our customers all the time, right, is making sure that these technologies are accessible. When we implement, we'll literally go onto the shop floor and embed with our customers and bring them, coffee in the morning and make sure they're comfortable using the technology, right? Because that is actually the most important point. If you have all of this sophisticated technology, it means nothing unless you drive adoption.
Yeah, it's a great point, Pat. Just interesting. When people are comfortable with it, they begin to understand the value, they begin to be using it consistently, and then we'll see the value upstream with the results it provides.
And I think the other thing is workers are really excited about this technology. They just want to feel like they're a part of it, not being replaced by it, right? They want to feel like they're a part of the transformation and the innovation, and that really drives the adoption.
Yeah, excellent, thank you. Let's move on to the third phase, which is exposing the data. Richard, why don't you talk a little bit about how Freshworks is taking some of the IoT data and exposing it at multiple layers of the organization?
Yeah, absolutely. So, with our ticketing solution, we feel that it needs to be collaborative in nature. So if you think about on a plant floor, there's a lot of influencers that are making decisions, and being able to collaborate and collect that data to essentially work on a ticket or an issue or an incident or a change, that's really where Freshworks comes in. So we partner with all these different IoT devices, sensors, data, and then we build these operating procedures, working with leadership on how they want to run their plant. And through time and data and analyzing, these organizations can become very smart on how they're getting these tasks done. And that's really where we're really excited because, to your point, it has to be easy, it has to be accessible. If everybody's working on the same platform, it really can drive amazing results.
Thanks, Rich, and it's something that I've often thought about as we talk about IoT. It's the right data at the right time in the right context. And so often, all of us who maybe talk with our wives and they talk about something and we're not in the right context, or like, hold on, what are you talking about? Right? We have no idea what context they meant. And I find that that's so often the case with a manufacturing engineer who goes back to their desk and they're like, oh, there's alarms. Wait, was that on line 3 or line 5? Well, let's expose that data in the right context so that they know how to be able to act on that. Pat, you want to talk about exposing that data a little bit more? how you guys are doing that?
Yeah, absolutely. So, when we think about exposing data, it's all about, again, and this is a consistent theme, meeting the customer where they're at, meeting their team where they're at, right? And so for some customers, they have incredible data architecture, they have a massive centralized MES system where they can pull all this data into a data warehouse and do tons of analysis and come up with their own conclusions. To be honest, that's rare, right? That there's no such thing as 100% clean data. And a lot of times we're working in legacy data environments where it's not easy to integrate. It's not easy to pull data from different sources. And so for us, again, meeting customers where they stand, we have customers where we'll do entirely greenfield or entirely kind of net new data and reporting functionality that they can use to see some of this defective data. Others where we can integrate into these massive systems, right? And so exposing for me is all about tailoring to the needs of the user, meeting a customer where they stand, because there's no such thing as a perfect data environment.
Thanks, Pat. Evan, thoughts there?
Yes, I would say that to me, exposure is about really trying to enhance the overall efficiency of the ecosystem. And with decentralized systems like blockchain, where the people own the network and have that data sovereignty that I mentioned before, they can employ what are called zero knowledge proofs, where they're able to aggregate information such as location and peak usage without revealing specific information about individual users. Now, this adds value because for example, on a cell phone dashboard, a user in, say, the Helium network can see not only where their node is, but its proximity to other nodes, as well as the number of tokens that they're earning. And the way this creates efficiencies is that it allows for the effective scaling of the system by balancing supply and demand. For example, let's say they look and they say there is a high traffic area, they can add more nodes in. Or if there is another area that isn't being serviced, they can add nodes there. And then on the demand side, if someone wants to determine, do I want to use an IoT device on this network, they can actually ensure ahead of time through this transparency that there is sufficient coverage wherever they're located.
Yeah, perfect. Thank you, Evan. Closing thoughts from each of you. Let's start with Richard. Closing thoughts on, I'm going to say, IoT data and application and where you see it going today.
Yeah, I mean, I don't think it has to be hard. Just starting is important. We kind of built a technology that is easy to use, easy to support. So we can go into a lot of manufacturers, and you might not have a technical employee base, but having an interface that's easy to use and data that's easy to digest, we really can drive results. So yeah, I mean, data and processing and servicing is important to continue to grow.
Thanks, Richard. Pat, closing thoughts?
Yeah, I think my biggest thought is start small and start with bite-sized pieces. I was on with a manufacturer on Monday that is a print manufacturer, and he told me about his dream for a fully automated lights-out manufacturing facility with robots and with cameras and with everything else, right? And that's wonderful, and we're going to get there, but no one is going to get there tomorrow. So what is the digestible, the highest value, least effort step that you can take towards automation? I guess the closing thought would be if that is visual inspection, I'd love to talk.
Thanks. No shameless plug there at all.
Exactly.
Evan?
So if you all can envision a Venn diagram consisting of 3 circles that overlap wherever they share common elements. If the first circle is industries and applications being disrupted by IoT, the second is industries and applications disrupted by blockchain, and the third is industries and applications in which this region has sustainable competitive advantages. What you will see is about an 80% overlap amongst each circle with each other, which is then going to create in the center this big intersection of more than half of all of the industries and applications. And what that's going to create is a tremendous opportunity for this region, extending from Detroit to Cincinnati to Pittsburgh to Buffalo, encompassing Ohio and here in Northeast Ohio.
Awesome, Evan. I'm reminded of the recent survey that was done by Magnet, and they were looking at the advanced manufacturing capabilities in our region. And only 15% of them were considered to be at the advanced level. So there's a lot of opportunity in our region. How about a round of applause for him?